Today I want to go over 9.1. Now 9.1 is going back over a concept that you have already gone through last year. It is Pythagorean theorem. And most of you are familiar that Pythagorean theorem is only done with right triangles. The triangle is labeled as such. The A and B are my legs and the C is a hypotenuse. The Pythagorean theorem states in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So what it's saying is C squared is equal to the squares of each legs summed to each other. Now, there are some common Pythagorean theorem triples and some of their multiples that you do know. You may not realize it until you start working them out. But some of them are going to be 3, 4, and 5, 5, 12, and 13, 8, 15, 17, and 7, 24, 25. And they are in the order of A, B, C, respectively. Now, having those there means that any multiple that you can multiply all three of them by means that the triangle itself is also a perfect right triangle, or it fits the Pythagorean theorem. So in this case, if you multiplied the first one by 2, that would be 6, 8, and 10. If you had multiplied it by 3, it would be 9, 12, and 15, and so forth. So for each column, you could list the variety of different ways. So if you multiplied this one by 2, it would be 10, 24, and 26. And you can keep doing this until it gets to be pretty much too large to work with. But as you can see, the formula basically goes 3 times whatever multiple, 4 times whatever multiple, and 5 times whatever multiple. As long as they are all multiplied by the same thing, you will always get a triangle that fits the Pythagorean theorem. Now, we can utilize this when we are working in this assignment. So the converse of the Pythagorean theorem states this. So for my converse, we draw another right triangle. We know this is A, this is B, and this is C again. Now, we learned this concept a couple chapters ago. If this side is my B side, then this has to be my B angle. If this side is my A side, then this over here has to be my A angle. And if this side over here is my C side, then this has to be my C angle. So the converse basically is just reminding us that the angles are across from there. So if the square of the length of the longest side of a triangle is equal to the sum of the squares on either of the sides, then the triangle is a right triangle. So basically it's reiterating the right triangle theory based off if I give you angle amounts and they end up being Pythagorean theorem wise. So this then rolls into our inequalities. So a Pythagorean inequality states that if I have something like this, now inequality means that we know it's not a right angle, okay? So it's either going to be acute or obtuse. So let's talk about acute first. So for an acute inequality, once again, let's label this. This is going to be B this time, this is A, and this is C. So A angle is going to be here. The B angle will be over here, and the C angle will be over here. The theorem that gets us through this states that C squared is larger than the sum of the other two squared. So A squared plus B squared. Okay, if that's true, then the triangle is actually acute. The obtuse states basically the same thing. So let me redraw it. So I didn't do a very good job of that. But let's say we have this, and this right here is my angle. So the obtuse one would be, let me redraw this, sorry about that. There we go, that's more of an obtuse. Looks like this. So if this side is A, and this side is B, and this is C, the corresponding angles are the same. This one's C, that one's A, and this one over here is B. So once again, if I have an obtuse angle, we know that the Pythagorean inequality theorem states that C squared would then be greater than A squared plus B squared. Now, let's go through some examples of these to see which they are. So it asks here on practice problems 1 through 3, it says find the value of x, whether the side length forms a Pythagorean theorem. So we're asking if it's Pythagorean theorem, and then what is x. We're asking two things on the questions, actually 1 through 6. So for example 1, we have a right triangle, and it gives us it's a right triangle. So we have x, 81, and 108. Like I said, it gives us it's a right triangle, so we don't have to guess if it is or not. So the first thing I'm going to do is do my formula. So a squared plus b squared equals c squared. Now remember, we know that the longest length in a triangle is known as a hypotenuse. So in this case, the hypotenuse, or longest length, is going to be x squared. 81 squared plus 108 squared. So now we need to do a little bit of math here. So we have 81 squared, which is going to give us 6,561 plus 108 squared, which is going to give us 11,664. So now we're going to add those two, and we are going to get 18,225. So our last step is to square root this. So I'm going to square root 18,225, and we're going to get the perfect 135. So x is 135, and since it came out as a whole number, we also know that it is going to be part of the right triangle Pythagorean theorem mix. So let's look at the next one. The next one we have here is for number 2. This is also a right triangle because it's given to us. This is 4, 8, and x. So this time, instead of missing the c squared, we are missing the b. So once again, I set up my formula. A squared plus b squared equals c squared. We plug in the 4 for the a. We leave this b squared because we do not know what it's going to be, and then we have 8 squared. So we multiply these, or actually square them, so we're going to have 16 plus b squared equals 64. So b squared equals, so in this one we have 64 minus 16, which is going to give us 48. Now 48 is not a perfect square. So in this case, this is not going to fit into the Pythagorean theorem this time. So let's see what kind of triangle we actually have, because we're looking at this angle up here. So what I have here is b squared equals, actually let's just make this easier, b equals square root 48. Now this is something that you may not have done in a while. I will do a video on actually taking and simplifying radicals. But for now, let's just assume that we remember this. So 48 is going to break down into 16 times 3. The square root of 16 is going to give me 4. So this is 4, and since 3 does not have a perfect square root, we are going to then rewrite it just under the radical. So the answer is b equals 4 square root 3 for my x value. Now be very careful because they want them precise, so making them into decimal is going to cause more issues. So now I want to go down. Let's skip down to number 5 because, of course, we want to make sure that we have a little bit of everything. So for number 5, we have this lovely right triangle also here. This here is x, this is 55, and this is 77. So first thing I'm going to do is set up my equation. A squared plus b squared equals c squared. So I'm looking at a squared plus 55 squared equals 77 squared. Once again, we look at our calculator here. 55 squared is going to give us 3,025. I'm going to recopy the a squared. And then 77 squared is going to give me 5,929. So let's subtract the 3,025 over, and that's going to give me a squared equals 29,004. Now, since I'm probably not going to know that, I'm going to take and try square rooting it. So when you square root 2904, we get a decimal. Okay, so we know that we cannot square root that. So now we're going to have to go back and do a little bit of legwork. So a is equal to the square root of 29,004. And since it ends in 4, I know it is divisible by 4. Let me scoot this up a smidge. So 29,004 divided by 4 is going to be 276. Well, 726 is going to be divisible by 2. So I'm going to try it by dividing that by 2 and see what I get. Okay, so I can divide a total of 8 out of this. And it's also divisible by 3 and 11. So I have 11 and a 4. So that means 11 times 4 is 44. So let's try 2, 0. Let's put this back in. We're going to divide the whole thing by 44. And it comes out 66. So basically, I can take out an 11, a 121. So go back to the beginning, 2,904 divided by 2, or 121, and I get 24. So I'm going to make this into 121 times 24. So this is already a perfect square. This one here, though, we can take a 4 out of. So if I break this down by 4 and 6, then what I'm going to end up with is 2 perfect squares that can come out. So 11 and 2 is going to be 22 square root 6 as my final answer for this particular problem.